This is the screencast for section 6.4, example 2. We're going to find all polar coordinates of a given polar point. So in other words, there are infinitely many points that have the same location as a given polar coordinate. So for example, the point 3 comma pi over 3, so r is 3, theta is pi over 3, occurs in quadrant 1 a distance of 3 from the origin at the terminal ray pi over 3. Now, because of coterminal angles, that point can be replicated by 3 comma pi over 3 plus 2 pi, pi over 3 plus 4 pi, pi over 3 plus 6 pi, etc. So we can say that that happens at 3 comma pi over 3 plus any multiple of 2 pi because of coterminal angles. Now we have to specify this happens when n is any integer. But that hasn't covered all of the polar coordinates that have that same location as 3 comma pi over 3. What about when the terminal ray ends up in quadrant 3? We could create a negative r value and it would still end up in the same spot. So for example, if I had theta, which was, let's see, pi over 3 plus pi. So first of all, my r value is going to be negative, and then pi over 3 plus pi. I'm still going to end up in the same quadrant, the same distance away from the origin. There's also coterminal angles of that, so I have to add 2 pi n to that expression. Now with a little bit of algebra, I can come up with the expression that your book gives of how to write this out. So I could factor out a pi, and then with a little bit of rearranging, get exactly how they wanted you to express it, which basically means I'm not dealing with coterminal angles of pi over 3, but coterminal angles of pi over 3 and another pi. So it's an odd multiple of pi that I would have to add to pi over 3. 2 times an integer would be even, and then plus 1, so odd multiples of pi. The now try problem number 23 asks us for polar coordinates that have the same location as point P. So point P is located in quadrant 1, and it is a distance of 2 away from the origin on the terminal ray pi over 6. So first of all coterminal angles of pi over 6 would create a polar point of the same exact location. So 2 comma pi over 6 plus 2 pi n. I also have to think about if r was negative, I could have another pi added on to my initial radian, and then the distance would go the other direction, still landing in quadrant 1. So it would be negative 2 comma pi over 6 this time plus parentheses 2n plus 1 pi. Now these expressions also cover any negative angles, because since n is any integer, that means n could be negative angles going clockwise as well.